Venus, often referred to as Earth's evil twin, is a planet of extremes. From its scorching surface temperatures to its toxic atmosphere, it is a world that is seemingly hostile to life in every conceivable way. Yet, despite these extreme conditions, Venus continues to be a subject of fascination for scientists and astronomers around the world. Why does this planet, which at first glance seems to have little in common with Earth, captivate our imagination? What secrets are hidden beneath its thick cloud cover, and what can we learn from this fiery world about the potential for life elsewhere in the universe? In Roman mythology, Venus is the goddess of love, beauty, and desire, but the planet that bears her name presents an entirely different face. The modern Venus is a planet so inhospitable and extreme that it challenges our very understanding of what it means for a planet to be capable of sustaining life. Yet, despite its current status as one of the most extreme environments in the solar system, Venus may have once been very different. In fact, some scientists believe that Venus may have had conditions more similar to Earth in its distant past: moderate temperatures, oceans, and perhaps even the potential for life. The question that has haunted scientists for decades is this: could Venus have been a habitable world, and what caused its transformation into the hellish landscape we see today? The story of Venus's exploration is one of remarkable technological feats and ongoing discoveries. In the 1980s, Soviet space probes known as Venera were the first to provide real images of Venus's surface. These images revealed a harsh, rocky, and barren world, quite different from the lush, temperate planet many had once imagined. However, these early missions also offered tantalizing glimpses into a planet that had once been far more geologically active than it is today. The surface of Venus was shaped by volcanic activity and tectonic movements that took place relatively recently in the planet's history, at least, in terms of geological timescales. The planet's surface appears to be geologically young, with volcanic eruptions and lava flows evident in the landscape. This discovery indicated that Venus was once a world of considerable geological activity, similar to Earth in some ways. But the exploration of Venus did not stop there. Fast forward several decades, and space agencies around the world, most notably Japan's space agency JAXA, have launched new missions to further unravel the mysteries of this enigmatic world. In 2010, Japan's Akatsuki mission arrived at Venus with the goal of studying the planet's dense, sulfuric atmosphere. Akatsuki, meaning dawn in Japanese, was designed to explore the dynamics of Venus's atmosphere, which is so thick and opaque that it completely obscures any view of the planet's surface from space. Through Akatsuki, scientists were able to gain their first real insights into the nature of Venus's atmosphere, revealing the presence of large, stationary wave structures, the peculiar phenomenon of superrotation, and some incredibly complex weather systems that suggest a much more dynamic atmosphere than previously thought. One of the most intriguing discoveries made by Akatsuki was the revelation of the planet's superrotating atmosphere. On Earth, the atmosphere rotates along with the planet at roughly the same speed. However, Venus's atmosphere behaves in a strange and fascinating way. It rotates much faster than the planet itself. In fact, the clouds in Venus's upper atmosphere complete a full rotation around the planet in just 4 Earth days, whereas the planet itself takes about 243 Earth days to complete a single rotation. This difference in rotational speeds, known as superrotation, is a phenomenon that continues to puzzle scientists. What causes the atmosphere to rotate so quickly? Researchers believe that thermal and dynamic processes, possibly in combination with solar radiation and chemical reactions occurring in the clouds, might explain this strange behavior. Regardless of the cause, this discovery revealed that Venus's atmosphere is far more complex and active than anyone had imagined. In addition to the superrotation, Akatsuki also provided new insights into the cloud structures on Venus. These clouds are composed primarily of sulfuric acid and are arranged in large, arc-shaped patterns that stretch over thousands of kilometers. These cloud formations hint at the complexity of Venus's atmospheric dynamics and suggest that the weather systems on Venus are far more active and intricate than previously thought. While Earth's weather is driven by the exchange of heat between the atmosphere and the surface, Venus's weather seems to be shaped by entirely different processes, including the interaction between the planet's surface and the upper layers of its atmosphere. This discovery added yet another layer of mystery to Venus's already complex environmental systems. But what about Venus's surface? For years, scientists have speculated that the planet's surface may have once been more hospitable, with liquid water and moderate temperatures, conditions that could have supported life. This hypothesis was based on the understanding that Venus, like Earth, is located in the so-called habitable zone of the solar system, the region around a star where temperatures are just right for liquid water to exist on a planet's surface. However, Venus's current surface temperature is anything but moderate. With an average surface temperature of 465 degrees Celsius, 869 degrees Fahrenheit, Venus is hotter than Mercury, despite being farther from the Sun. This extreme heat is the result of the planet's thick atmosphere, which is rich in carbon dioxide. The dense carbon dioxide traps heat through the greenhouse effect, creating an oven-like environment on the surface. This is a stark contrast to Earth's much more temperate climate, and it leads to the question, how did Venus end up like this? Theories abound about the cause of Venus's extreme greenhouse effect. One prevailing theory suggests that Venus may have once had oceans and a more temperate climate, but over time, the planet experienced a runaway greenhouse effect. This is a process in which heat is trapped in a planet's atmosphere, leading to an increase in temperature that causes water to evaporate, removing the possibility of liquid water on the surface. As the water vapor rises, it creates an even stronger greenhouse effect, which further accelerates the warming process, eventually driving the planet into the uninhabitable state we see today. In essence, Venus may have started out as a habitable world, much like Earth, but over millions of years, the runaway greenhouse effect turned it into a hellish landscape. What's more, recent discoveries have only added to the mystery of Venus's transformation. In 2020, astronomers announced the discovery of phosphine gas in the clouds of Venus. Phosphine is a chemical compound that is produced on Earth primarily by biological processes, and its presence in the Venusian atmosphere sparked a flurry of excitement and speculation. Could this gas be a sign of microbial life in Venus's clouds? While the exact origins of phosphine on Venus are still unclear, its discovery has led scientists to reconsider the possibility that life could exist in the planet's upper atmosphere, where the conditions are not as extreme as on the surface. The clouds of Venus, which are located at altitudes where temperatures are a more temperate 30 to 50 degrees Celsius, 86 to 122 degrees Fahrenheit, could provide a more suitable environment for life, particularly microbial life. The discovery of phosphine has thus opened up a whole new area of research into the potential habitability of Venus, suggesting that life might exist in places far more extreme than we previously thought. Despite the harsh conditions on Venus's surface, the possibility of life in its clouds is not as far-fetched as it might initially seem. While Venus's surface is far too hot and toxic for any form of life to survive, the atmosphere of Venus is a different story. The clouds that swirl around the planet are rich in chemicals like sulfuric acid, which is toxic on Earth but might not be a barrier to life in an alien environment. The clouds also provide some protection from the harsh radiation of the sun, shielding potential life forms from harmful ultraviolet rays. Furthermore, the temperatures and pressures in the upper atmosphere are not as extreme as on the surface, making it a potentially more hospitable environment for microbial life. While scientists have yet to find definitive proof of life on Venus, the discovery of phosphine has given rise to a new field of research into the possibility of microbial life in the clouds of our fiery neighbor. As scientists continue to study Venus, new missions are being planned to further investigate the planet's atmosphere, surface, and potential for life. NASA has recently announced plans for 2 new Venus missions, named Veritas and Da Vinci Plus, both of which will launch in the coming years. Veritas will focus on mapping Venus's surface and studying its geological history, while Da Vinci Plus will study the planet's atmosphere in detail, including the possibility of life in the clouds. These missions aim to provide more detailed images of the planet's surface and better understand its geological processes, as well as to investigate the composition of Venus's atmosphere in an effort to unlock the mysteries of this extreme world. As Venus continues to capture the imagination of scientists and space enthusiasts alike, it serves as a stark reminder of the delicate balance that governs a planet's climate. Venus may have once been a more hospitable world, but a runaway greenhouse effect transformed it into the hellish landscape we see today. This is a cautionary tale for Earth, showing how easily a planet's climate can spiral out of control. While the conditions on Venus may seem too extreme for life, the discovery of phosphine in its clouds has reminded us that life can exist in even the most unlikely places. Venus, with all its scorching heat, toxic atmosphere, and mysterious chemical processes, continues to be one of the most fascinating planets in our solar system, and our quest to understand it is only just beginning. The possibility of life on Venus may still be uncertain, but one thing is clear: this planet, with all its harshness, continues to offer valuable lessons about the nature of life in the universe and the fragile balance that sustains it.